So today we're going to go back to the concept of percentage, except today we're going to deal with percentage change. What we dealt with already this year is basic percentage problems where we had that percent over 100 is equal to is over of. Percentage change, I use a different terminology. The percent over the 100 is equal to the new value over the old value. Sometimes we'll call that old value the original. Or the percent over the 100 is equal to the part over the whole. Now I'm going to diverge a little bit from the way the book teaches this. If you'd like to read through the book, do it the way they suggest, knock yourself out. I kind of like this other way. So in this case, they want us to state whether we've got an increase or a decrease, and then find the increase or decrease percentage. Now you'll notice we start with an original of 52 and go to 75, so this is obviously going to be an increase. And we start with an original of 84 and go to 33, so this is obviously a decrease. Those are the easiest parts of the problem. Now we want to find these percentages. So if my original is 100%, 52's got to go across from that. If my new percent is what I'm looking for, then 75 would go right here. So now I'm going to take a cross product. Multiply 100 times 75.5. That should be equal to, I'll call this unknown percentage x. Put an x right there. So that's equal to 52x. This is going to be 7,550 is equal to 52x. Divide both sides by 52. And what I end up with is a total of 145.19%. Now, the thing is, this problem isn't done, because what I did was I started at 100%, went up to 145.19%. So the actual answer to this, because they wanted to find the percent change is actually going to be the difference of these two numbers. So that's a total of 145 minus 100. You know, 145 minus 100 is going to be a 45.19 increase in percentage. So let's take a look at the other example. We're going to go from an original of 84 to a new value of 33. Do the cross product once again. I get 84x is equal to 3,300. Divide 3,300 by 84. And I end up with 39.8%. Again, this problem is not done because we started at 100 and we went to 39%. So if I take the difference of these two, I get my percent change. So I go 100 minus 39.28 and I get a 60.72% change. And let's just look at both of these. In this case here, I dropped more than half from 84 to 33. So I should be dropping more than 50%. In this case, I certainly didn't double. Doubling means you increase by 100%. And if I were to double this, this would be about, what, 104? 75 is about halfway there. So if doubling is 100%, half of 100% is about 50%. So that was a 45% increase. Makes sense. You've got to kind of look at your answers in the end and ask yourself, does it make sense? So here are some word problems. Ann works at a supermarket for 10 bucks an hour. Her pay is increased to 12 bucks an hour. And we want to know her percent increase. So certainly she's not doubling. All right, she's going up relatively small comparatively. So we should be less than 50% on the increase. But let's find out. So what I have is I have a percent over 100 is equal to, I like the new over the old in this case. So we have an unknown percent. That's over 100. The new value is 12. The old value is 10. Do the cross product. Get 10x is equal to 1200 x after dividing both sides by 10 is equal to 120%. Does that mean she went up 120%? Definitely not, because she would have doubled her salary. I went from 100 to 120%. Therefore, that percent change is found by taking the new percentage minus the old percentage, and that gives me a 20% increase. So all these are kind of done in two parts. In the cases that we've done up to this point, those two parts have all happened. The second part's always happened at the very end. We get an answer for x, and then we take and do a subtraction and get our final answer for the problem. Let's see if that continues. So the next example, Ms. Thornton is interested in a particular bracelet. Its original price is 60 bucks. Its current price is 45, so it's on sale, and we want to know the percent decrease. This looks like a similar problem. We'll take, again, the new over old concept, so the percent over 100 is equal to the new rate, or the new value, over the old value. And what we'll notice is we have 4,500 is equal to 60x. We're going to take 4,500 and divide it by 60. That gets us an x value of 75%. Does that mean it was 75% off? Let's look at it. We started at 60. 75% is more than half off. If we're buying it for $45, certainly that's not the case. But 60 corresponds to the 100%. 70 or 45 corresponds to 75%. So I went from 100 to 75, and that difference is 25% off or decreased. All right, so here's a little twist. Jack sees a sticker price on a CD of $12.99. If the tax on the item is 9.25%, what's he end up paying for the CD? There's a couple of ways to do this. I like doing it a little bit different than you might be used to, but I say the original price of my CD is at 100%, and I call that the $12.99. Now, when they charge me tax, they're charging me more than the original when I walk out the door. How much more? 9% more than the original. If the original were 100%, then I have 109.25 as my increased percentage. And then I'm going to find my new value here. So this is kind of like the first part of the problem. The second part's going to solve, and then it should make sense when I'm done, because I've already done the first part, which is adjust the increase or decrease. So let's multiply 109.25 times 12.99. That should equal 100x. In doing these multiplications, I get 1,419.15 is equal to 100x. I'm going to divide both sides by 100. And that's going to get me a total of 14.19. And remember, these are dollars. So that makes sense. A couple bucks tax on $12.99, or a little more than a buck, and it gets me a out the door price of $14.19. So we got Jalen's car is 8 years old and it's decreased in value by 38%. And if the car was originally $29,587, what's it worth now? Again, I'm going to do the adjustment of the increased and decreased percentage right off the top. I know that the original price of the car is the 100%. And I know that original corresponds to $29,587. I don't know the new price of the car. I'm going to put that over here. But I know the value has decreased by 38%. So if I started at 100 and I decrease that by 38%, then I know I have a car that is 62% of its original value. So I'm going to put 62 up here. Again, I'll do a cross product. Take 62 times 29,587. Set that equal to 100x. Divide both sides by 100. And I end up with $18,343.94. So not bad for an 18-year-old car, held its worth pretty good. So let's look at the next example. You go to a sporting event, expect to pay a lot more for food. On the average, the markup of the food price is about 375%. So if you pay $7 for a hot dog, what it cost them to make. So really, you're paying almost 4 times the original price when you go to a game. So let's set this up. If I start at 100, I want to know what was the original price of the hot dog before they marked it up. Well, I don't know that, so that's what I'm going to call X. I know my new price is $7. And that is an adjustment of a markup of 375%. Well, if I started at 100% and I mark it up, or I increase 375%, that puts me at 475% now. So now I take my cross product, get 475x is equal to 700. Divide by 475 to both sides. And if I take 700, divide by 475, I get about $1.47 to make that dog. And that still seems kind of expensive. So anyways,